Okay, you can see clearly, though it is projected normal to it, but it need not be parallel to the other incline. Okay, here we have projected with a certain speed that is also not given, and it will strike the other incline normally here also. So you can, what you can do is you can proceed like this. So let this be the so let this be the point PQ. Okay, let me take this is N. Let me draw one line PN, which will be normal to the other incline. So that this, if you want, you can give the name like to the incline OB. Okay, look at the, let the speed of projection be U. So we'll resolve this. So you get one component will be, what can be this? If this is phi, 90, this will be 90 minus phi. Try to see the mathematics. It'll be very easy for you once you can get this. If this is 90 minus phi, this should be the phi. So what is this component now? U sine phi, shall I write? What about the other component? The other component will be U cos phi. U sine phi will be parallel to the inclined plane OB. I resolved it. And it will strike normally, no? So here you write few. It doesn't appear, so I just made a diagram like that. U sine phi will be parallel to incline OB. U cos phi will be perpendicular to incline OB. Okay, fine. These are the things. So now what you're going to do, you're going to resolve this G. So resolve the G now. So this will be how much? G sine beta. This will be G cos beta. G sine beta, and that will be G cos beta. Write the equation now. First, perpendicular to incline OB. Perpendicular to OB. And I'm proceeding with this. Perpendicular to OB. What is the final velocity? It will strike normally here, no? It will strike normally at Q. So therefore, what will happen to U sine phi by the time when it moves from P to Q? Will become 0. It is striking normally. So 0 is equal to U sine phi minus G sine beta time of flight. Try to see that. Why do the U sine phi will decrease? Why do that initial velocity U sine phi will decrease? Because of retardation G sine beta. V equal to U minus AT formula I'm applying. So when it strikes the inclined plane OB, it will strike normally at Q. So therefore, what happened to the component along OB? Decreases, becomes 0. Okay, there's a one equation. Okay, now after this, can we write this distance Pn? What can be the distance Pn? Sine phi equal to Pn by A. And the value A is given. So let me write one mathematics. Sine phi is equal to Pn by Po. So what is Pn is equal to? Po sine phi, which is equal to A sine phi. Come for this. Phi is what I assume, not given. Phi is what assumed here. What is phi will be? Alpha plus beta plus phi is equal to pi, no? It's assumed one, it has to be eliminated again back. What is Pn? Shall we say when the projectile moves from P to Q, the Pn will become range. Will I agree? As it moves from P to Q, the Pn will become range, no? So what is the displacement perpendicular to incline OB equal to Pn? And what it makes, the G cos beta will accelerate, and what is the initial velocity? U cos phi. So shall I write S equal to ut plus at square? So perpendicular to, oh wait, this is parallel to OB. Okay, next you write perpendicular to OB. Write one more equation. Distance Pn is equal to U cos phi theta plus G cos beta t square by 2. Try to see all the things I think in the diagram, and I'll make it visible. Writing this equation 1, 2 is what the concept. As it moves from P to Q, what is the displacement perpendicular to incline OB is equal to Pn. So Pn equal to U cos phi t plus G cos beta t square by 2. So what is further Pn? Pn is equal to A sin phi. So A.
Sir,
Yes, ma'am.
from equation 1 only can't we say the time of flight, sir?
You don't know, no? It's unknown thing, no? I'll write it. U is assumed. Phi is assumed. I should replace them, no?
Sir, it is G sin beta t by 2, no, sir. In first equation.
This one, huh? G cos beta, no? It should be.
First equation, sir.
First equation, G sin beta.
G sin beta t by 2.
V is equal to U minus dt, correct, sir?
G sin beta is a retardation, and U sin phi is the velocity. Okay.
Yes.
Fine. Okay. Now solving this, because say you can ask what's our equation 1. In equation 1, what when U is unknown, I should eliminate U. Phi, okay, I'll get eta. Pi minus alpha plus beta, phi I'll get from there. But U, I don't know. So therefore, I'll write one more equation. I'll eliminate U from here. I'll solve for T. I'll get the required answer. You can also get the value of U also. I'll write down the answer. You will later on clarify it. 2a sine square alpha plus beta G Okay, this is the expression for the time of flight. Okay, it's all about again equations of motion only. So what you should do, you should have a just basic idea of that. What is the trajectory? How the trajectory, how it makes. Then everything what's happening, you have to convert that parallel to incline, perpendicular to incline. Then apply equations of motion. I think whatever the type of numerical come, keep this in mind. That's all. So even if I discuss under numerical, the idea will be same. By this time you might have seen your teacher is not doing anything very big. Just is applying equations of motion.
Sir, we have a first equation now, sir. G sin beta t is equal to U sin phi. Where did we use that, sir?
I'm not getting.
Where did we use that, sir?
Where we use data?
Yes, sir.
What do you mean by that? Where do you use that?
Like, did we find it to just generalize the equation, or is there any need for that finding that equation, sir?
V को tuplicity formula.
Okay, sir.
V को tuplicity formula. Okay.
Okay, sir. Yes, sir. Thank you.